This is problem number 4 from section 2.4. In this problem they say an individual is driving a car along a straight road. The graph to the right shows the driver's distance from home after X hours. So if you see this graph here, you can see that this is the amount of hours a person's been driving essentially, and this is the distance they are from home. So I have this labeled with slope 1, slope 2, slope 3, and slope 4 because there's kind of 4 little pieces to this graph. Let's go ahead and look at part A. So part A says use the graph to evaluate f of 1.5 and f of 4. So f of 1.5, what does that mean? That means we're plugging in 1.5 into the function. So we're going to the graph and we're saying, all right, the x value of 1.5, that's the number, that's the time, right? That's the number of hours. So after an hour and a half, how far is this person from home? So we go 1.5 hours, we go up and we see that that person is 45 miles from home. All right, if we go right up in the middle, it's right in the between 40 and 50 miles, so it's probably 45 miles from home. Now keep in mind when you look at this graph, 0, 0, right? That means 0 time has gone by and they haven't left the house because they're 0 miles from home. F of 4 means after 4 hours, where are they at? Well, at 4 hours, it looks like they're 20 miles from home. Okay, what does that mean? Well, that means in the first hour and a half, they were kind of traveling away from home, right? Getting farther away, 45 miles away. And then for the last 2.5 hours, they've been kind of creeping their way back, 20 miles away. Okay, part B, it says interpret the slope of each line segment. Well, if we look at this slope and we were to find this slope, we would take the rise, which would be the distance, divided by the time. Well, what's distance over time? Well, that's a velocity, right? So these slopes here, they stand for the velocity of the car. So the slope stands for the velocity. We'll say, well, it stands for the speed. We won't say velocity because we don't know the direction of the car, or at least a specific direction. We know away from and to, but part C. Okay, part C says, describe the motion of the car. Well, let's look at what the motion is for 1, 2, 3, and 4. So for 1, that would be going away from home. Right? Traveling away from home. For part 2, that's towards home. Part 3, it's a flat line. Now, it's possible for a person to drive and not get any closer to home, but they would have to kind of go on like an arc, a circle around their home, right? If you're driving, you're moving, and that would be kind of impossible to do over an hour. So we're going to assume that they are stopped. And 4. Let's see. 4, that would be towards home and eventually reaching home, because if you look at f of 5, right? F of 5, we are 0 miles from home, so that means we're at home. Okay, so part D. Identify where f is increasing, decreasing, or constant. So we're increasing, all right? If you look, we're increasing from, basically from 0 to 2. So increasing, and I like to use interval notation, so I'm going to say 0 to 2. And I'm going to put parentheses there because obviously at 2 I'm not increasing or decreasing, and at 0 I'm not increasing or decreasing either. I'm decreasing from 2 to 3 and 4 to 5. And finally, this last part is When am I constant? I'm constant from 3 to 4. Hope that makes sense how we interpret that and how this graph is being interpreted.